Welcome to the HIT Lab New Zealand. My name is Stephan Lukosch. You haven't seen me today so far. I'm a professor here at the HIT Lab, joined it in 2019 as well, together with Heide, who we have seen already several times today. And this tour is basically about the present of the HIT Lab, and we will walk you through the HIT Lab and show you our great facilities, rooms, people that we have here, and we will show a lot of demos as well. And you can ask questions on YouTube, and you can leave comments. Chris, our cameraman on the other side, he will follow your commentary and relay these questions to us. Though I need to say there's a bit of a delay between what I'm saying and what you are seeing on YouTube. So if we are moving along, we might not catch your question immediately, but at the end of the tour, we will be more stationary and definitely come back to all your questions. So whatever you want to ask, put it on there, and we will come back to that. And at the moment, you are here at the entry hall, at the reception area of the HIT Lab. So over there is normally Karen, who has disappeared for a moment, but she normally welcomes everyone who comes in here with a smile. Behind Chris, you see the staircase where you come up from the lower floor of the John Britton building, and behind even that, you see basically the tremendous space that we have where we can have students, experiments, and workplaces. But the idea of the tour is to lead you through the whole lab, and we will go this direction first, and then we will stop every now and then in a few rooms to give you some demos and possibly some birthday surprises. Hey Chris, are you ready to follow us? Yeah. Cool. Oh, sorry. And yeah, Heide will accompany me on that tour, because sometimes I might not know what to say, and she might have a way better story to tell. So we will try to really continuously entertain you on that tour.
We will do our best.
Okay. I'm trying to walk backwards. What you will see here is basically student places. Here over here, there are our postgraduates from the MIT program. These spaces at the moment are empty, but would normally be filled with postgraduate students as well. Something that we are really proud of while we are walking here, we have new closets in here. We have real plants. They are not plastic. They're really improving our air quality. And what you also will see, we have a lot of virtual and augmented reality archaeology here, because we basically put out all the different head-mounted displays and devices that we have worked with over the last years. Okay. You're slowly approaching the PhD space. So over here they are the workplaces of all our PhDs working with us. Everyone has its own place. Around this corner here, you will find postdocs working at projects and working with us together. Here's also some kind of area where everyone can relax. Well, what you can see here is a lot of cables, a lot of computers, a lot of technology, and we'll continue over in that room, because this is our first stop. And in this room, basically, today, unfortunately, in this room, students in the MHET program can set up their experiments. Unfortunately, today, the student who was supposed to be here cannot be with us, Hayden. He was supposed to give a demo on his project, but there will be a presentation on his project later on, which is about simulating racket haptics for EXA games, and it's a really nice project, so we'll learn more about it. But during the MIT program, students can book the place, set up their experiment, and run the user studies.
As you've heard earlier today, that we discussed that space is a sparse resource at universities. So we are really, really grateful to have this space, which can be empty, that can also be filled with a lot of technology and people, and that students can book and then really keep it as it is, so that make sure nobody touches their setups and experiments and carry out safe experiments in the room. That's really great.
Yeah. So perhaps as a review, I think this year we had about 10 different user studies going through here. One was about, what did Helen work on?
An earthquake simulator.
An earthquake simulator. We had a student who looked into giving visual feedback during strength exercises and squat motions.
We had Harry Potter, which you will also see later.
Yes. Harry Potter moved over to the vision space. The squat motion feedback moved over to the entry hall, so you will see this. and I'm definitely missing out on a lot of demos and tests that were done here. Perhaps because I'm not recalling them, but it's better to move on to the next room. We go first. The camera is following us. Yeah. Thank you, Chris. So, you might have seen already, this is the Ken Beckmann Room that we have dedicated to Ken, and because Ken had such a big impact on the HIT Lab. And, well, we all had our morning tea here, we all had our lunch here, and because it's a birthday, and it couldn't be a birthday without a birthday cake, we have a HIT Lab 20th anniversary birthday cake, and Tom, would you do us a pleasure to cut the cake?
Well, I cut the cake.
And happy birthday to all of us.
Oh, look at this. Where's Rob? Rob.
Yeah, perhaps for Rob. Rob, I make sure that there's one piece left for you, and then we'll drop it off at your place.
Yeah. So, Rob, you're with us, I hope. Can you see me? I hope you can see me. But this is sort of all because of you, you know, that we've survived this long. And so you should be doing this. But I'm honored that I get a chance to do it. So you've probably seen it. Happy 20th birthday, HIT Lab New Zealand. How many pieces do we have to have? So I'm just going to go straight down the middle. Is that okay?
I think that's a good
Okay,
approach.
that's right. Here we go. And is Mark here? Where's Mark?
Mark is watching us on YouTube.
Okay.
He will see what you're doing in 20 seconds.
Okay, let's see if I know how to do this. Here we go. Oh, this is going to be a good cake.
Yummy.
Now some professional has to take it from here to get the pieces right. Oh, you're going to be the professional, okay.
I always take a square approach to that. Oh, wow, that's
Okay.
delicious.
Well, this is my piece here.
Okay.
Yes.
I thought I could bring that one to Rob.
Okay.
What do you think?
I don't know. What do you think the count is?
Maybe
Everybody has to eat a piece, so. Yeah.
I will just do one.
And the audience's reaction just arrived in our room. Stefan mentioned already that this is called the Ken Beckmann Room. It's usually used for larger meetings, for our lab meeting on Fridays, where we share updates from the group, where we invite external speakers. It's a really social and positive space. In non-COVID times, we also share Kai, which is of course a really important element to build like a culture and a group in the lab. And in the back, you also see one of the students' artwork. It's the so-called Silly Cube assignment to become a little bit familiar with Unity that Ryan runs for one of our master courses, and that's the result. A lot of silly cubes. And the cake is cut, I think, so please take a piece to celebrate.
I think we basically move on, right, because we're on a time schedule. But I would be happy if one piece is left for Rob and one piece for me, because I know how spongy that thing is.
Well, we'll leave another piece for Ken.
Okay.
And we'll see what happens to it. You know, if he decides to show up.
Yes.
Take care.
That's always good.
That's a good idea.
All right.
Rob says he's watching from the chat, and then people are asking how can they get the cake through the 360 camera.
We're working on that side of the technology.
Well,
Not there yet, but we work with a lot of interesting technology.
Shall we deliver this?
Yes. I think we move on because we have a really strict schedule.
Okay.
Everyone, take a piece. It's birthday. Enjoy.
Okay.
So our next stop will be the first. Oh, we passed by. Sorry for that. Here you see a small meeting room that we have next to the Ken Beckmann Room. So again, students can book the room, to have meetings. We always use it also for project discussions. So when we have industry partners coming in and have a smaller group discussion, we can go into this room and have a more private area to discuss what needs to be discussed. Okay. Here's Rob's office. I know that he wanted to show how his office looks like, but I fear it's blocked. But he has a very special office. Passing by Heide's office, passing by Andy's office, passing by something that we have discovered in our storage space. And previously in the HIT lab, everyone who has visited the HIT lab left behind a picture, and the picture was shown then on these boards. And I don't know how many of these people that are on that board are currently online with us as well. And I'm way better with the other board, because the only person that I immediately could recognize on this board is Tobias Langlotz, who is now an associate professor at the University of Otago in Dunedin, and with whom I organized the IEEE VR conference this year, and we will do the same thing next year, but with more support from our colleagues in China. I think now the idea is to go into the first demo space. And here we meet Mac Greenslade, and he's a current student in the MHIT program, so from the 2021 cohort. And he worked on using everyday objects in augmented reality. And in order to make that possible, he will talk a bit more about that, but I would like to give you that impression here. He used basically the motion capturing facility that we have here. And this is really state-of-the-art motion capturing facility, an OptiTrack system with, oh no, I'm challenged again, I think 15 cameras that are tracking, that we can use to track body motion, but also the motion of everyday objects, as Mac will demonstrate. I move you out of here again, and you go. So you should be able to see what Mac is seeing in the HoloLens that he's wearing on that screen over here.
Take my mask off because it tends to fog up the HoloLens. Yeah, so my research was all around how we can use everyday objects for augmented reality interactions. So, bring my study up now. I won't talk too much about it because you'll see in the video coming up in the next section I go into a bit more detail. The idea with the study was that people would select whichever everyday object they'd like to use for the study. In my situation, I'm just going to use this mug, but I'll use it to become a sword, and then a shield, and then a crossbow for some little game tasks that I've set up. I was just using the QR code there to align the coordinate system of the HoloLens with the OptiTrack system. So I'll go next task. I'll bring my mug, and I'll use it as the handle of my sword. Set. 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 Show. The voice controls have decided they don't want to listen to it. Unfortunately, this was working fine just moments before we brought the live stream in. Set.
The same happened to us just minutes ago, so don't worry.
Show.
Don't worry.
Maybe if I'll quickly try and exit and reopen the thing, see if that helps.
That's fine. So the whole purpose of that research is, while Mac is working to restart his application, is that very often the moment you interact in augmented reality, you use your free hands, and there's something that is called arm fatigue, hand fatigue, and if you really need to select all the things just with your hands, you can get tired very quickly. Again, also working with the virtual objects or interacting with virtual objects, very often you really miss out on haptic or tactile feedback
Set.
that you could get from using an everyday object, for example.
So it seems to be behaving now, so you can see now my
Yes.
mug is controlling this virtual sword. If I go next task, a bunch of training dummies will show up, which I can stab at with my mug/sword.
So if you imagine that work is going to be completed, You might in future play an augmented reality game at home, and you might just use objects that you have at your hand in your home and turn them into a controller to control your interaction.
So now my mug has become a shield that I'll use to defend myself against some crossbows which will start firing at me. Next task.
Thank you, Mac.
It is really, really cool.
Let's move on.
Cool.
Yes. I will pass the camera to Chris.
Yes.
Thank you. And we will pass by a way larger board with alumni. And I know a lot of faces and don't know everyone personally, but again, you will find Tobias here. But there's also Gun Lee, who is now in Mark's group in Australia, in the University of Adelaide. And you can see these pictures are rather a bit old. None of them is really looking like that anymore. I can say that because I'm not looking like myself, well, 10 years ago as well. Some people might even know, where is it, Daniel Wagner, for example. And there was some person down here that was, very famous, Hirokazu Kato, with whom Mark developed the AR toolkit, which is basically, one of the foundations of the HitLab here. Okay, carry on. So here we come to our second demo. Tim, a PhD student here in the HitLab at the moment, who works on video game development processes for applied immersive gaming and how they can be developed. But he was so kind today to demo our Omni platform. So the Omni is an omnidirectional platform where you basically can be strapped in. And while you're in there, you can see that Tim's shoes are kind of slippery, and with that he can basically walk in virtual reality. And we created a few virtual reality experiences to basically experience and get the impression on how it is to really be in that environment and to be physically active, and how that helps you to mitigate cyber sickness, and how that might increase your perception of presence in that environment.
Which is really important when you want to create realistic training environments, for example. So if you think of firefighters training with this device, it could be really important that they feel the same stress and exhaustion as in a realistic situation. So this could help them to move around and to feel like a similar level of stress as in a real situation. So you see Tim walking around in a park-like environment, running. And if you're strapped in the machine, it's really safe. You can't fall over, even not when you're attacked by a dinosaur. But Tim survived. That's good.
That's a good thing about doing these kind of things in virtual reality, right?
Sure. And it's a lot of fun. Like,
yes.
Fun
It is a lot
important.
of fun, I know it.
But what you could actually see with Tim being in there, you cannot only walk slowly, you can even run. Though it might look awkward from the outside, the moment you are in that environment and you have done your first steps, it really starts to feel real. That's at least our experience so far, and gives you the experience of being in that environment and trying to walk there and run.
When you have the right motivation. When you have the right motivation.
When you have the right motivation, well, that's always the case, right? Okay, so being here, looking down this direction, this is basically the second half, or the other end of the John Britton building on the first floor. This is all now HitLab as well. We have even more workspaces here for students that can come in here. So I'm going to run, for example, a mixed reality course in semester 2, and the students that are in that course will come in here and do their lab assignments and work on their lab projects or course projects in here. And at at the very end, basically, there's Ryan's workspace. Ryan is our professional game developer, and Shun's workspace, who is our 3D game artist. And from here, we move over to this side, because here we have another student's space, where students can basically set up experiments. So you see the remains of a project that one student carried out during this year's MHIT program, and that was about creating a virtual flame experience and basically creating an electric fireplace in augmented reality. We continue onwards, and we will pass by our tab lab. We have a mark here as well, but we'll keep it very brief. In here, students can basically 3D print equipment that they might need for the user studies or for the objects or controllers they would like to build. So we have a soldering station, we have 3D printers, and we have a lot of small parts that they can use basically to create their new devices and whatever they need for creating immersive experiences.
It is part of the MHIT to at least get a little bit of insight into how to 3D print, for example, what is needed, what kind of software to use, how to create the virtual models and then turn them into physical objects. And it is part of the MHIT project just as one lecture, but it's much more that like the students get really interested in it and be more creative in the things that they are doing, and not only creating like software, but that they think beyond that, and it's really opening up the possibilities of our education and the research that we are doing.
And one thing that you might see here at the moment as well, because the sun is coming out, the HIP lab is really a bright space with a lot of light, because the staircase has this glass cube, so if the light is coming in, we have these glass ceilings up there, so there's a lot of light coming in here. I need to say that's not every time really good for running user experiments, especially if you do some things with augmented reality, then the sunlight might be a bit more distracting, but it's a great space to work. So let's carry on.
Oh, it's good. Good. You guys have it heavy. You guys have it heavy.
Please join us.
So we are back into the entry hall, and here we have basically 3 demos that we always have up and running. So for people who come to the HIT lab, basically that they can get an experience with the work that we do. And I hope, Adrian, that you are online, because you will obviously remember what you have built here. And you always say like, it's not as good as it was before. I still think it's an awesome experience. So you can basically, this is from an arachnophobia project where you can have spiders and grab spiders and lift them up or let them fall down again. For me, the most memorable experience with this system is that we had the mayor of Christchurch in here, and she said she doesn't like spiders, and she picked up one and she really cried out like, "What?" So, well, that's a virtual one. This is also Adrian's project, if I remember correctly, and that was basically on Jack the Time Traveler, and the idea was here basically bringing together virtual reality and augmented reality and the real world. Adrian always says that the great thing about this system is actually, and now we see the light issues, let's see, the great tracking that has been implemented here in the registration, because you can go really shallow, in a shallow angle, and the tracking stays stable. And the interesting thing is also the moment you move out, it remains like that. And if you move in, you're getting more and more into the virtual world, right? No, I need to use another page. I need to go to
And even though Adrian is complaining that we're still showcasing the old work, especially when we have guests who are not so familiar with the technology, these are so great examples to illustrate what VR is and AR and like what the core technical challenges are. Because as Tom Ormark said earlier, you can't explain VR without showing it. It also helped us a lot in COVID times when it was hard to illustrate it by using ad-mounted devices, to have something that people don't have to touch, that they can just walk by and try out and see what we can do or what we have done. So that's really great to still have in the lab, even if it's a little bit older.
So you will have seen it while Heide was talking that I was moving the camera in and out, and the closer I was coming to the comic book, the more I was into the virtual space, and in that page, in fact, on the in space, dealing with an alien on a satellite. This is actually a project that Leon worked on. You will see Leon behind Tom over there waving. Leon is also a current MIT student, and he worked into giving visual feedback during strength exercises, and specifically doing squat motions. And the idea was, if you could give people who are doing a squat motion feedback on what they are doing and correct wrong movements, they might have less injuries. So he developed this magic mirror setup that basically uses a Kinect, it tracks my body motion. I need to say it's calibrated on Leon, so I need to exaggerate on what I do. But if I do a correct squat, like everything stays green, oh, it's getting yellow, but I can at least stay in green. And if I do something completely wrong, like moving my knees inward, I get the feedback that I'm really not healthy at the moment. So this is and he ran a user study on different visual feedback modes. So we have this traffic light set up, but there were also arrows or a ghost or an avatar that basically showed what you were doing wrong. And you got some really nice insights. So stay tuned. There will be some thesis publications of that. So from here we move on to our largest space in which we set up our virtual reality equipment. And here we will have basically different demos, Tecna cages, right? So that would be over here. So these Tecna cages are multisensory platforms for experiencing virtual reality. And Rob brought them actually from WPI when he came to the HIT lab. They can simulate or stimulate different senses. So you will see here that there are some fans, so we can basically simulate wind. There's a smell cannon, we can simulate different smells. And then there's this vibration floor that can simulate or give you vibrational feedback. And I need to point out that there's a difference between this Tecna cage and this Tecna cage, because here the fans can also be tilted and moved out of the way so that we do not have only wind in one direction, but we can also quickly stop the wind. And this is a new smell cannon that Ryan, we will meet Ryan in a few minutes, has created. And I actually don't know.
We can ask the creator.
Yeah, I think he's busy setting up another demonstration.
So, busy. Okay. We will come back to Ryan. If you want to know more about the smell can, Ryan will be there in a moment. My understanding is that it's way better in basically loading a smell and releasing a smell into the space than the system over there.
I can help you building a little bit, actually. Okay, thank you. So I'll just jump in. The early version of the smell system, we actually put up the electric fuming system onto the fans. And then we heat the fume and then blow the smell to the people sitting there. But because this is not enclosure, that when we're heating up the oil and inside the container, the smell already fuses up. But the second generation, if you can see, it's all closed up. So I don't know how I can show details. It's like a self-contained chamber, and then we use electronics to control these louvers here. So they will only open up when you start to blow the olfactory elements to the participant. So otherwise, it's well contained and you don't have any leaking outside. So that's like a second generation, solve a lot of problems.
And at the moment, we can do tar, lemon, grass, and undefined.
And you may ask yourself, why are we doing all that? So how we are doing that is being a research lab at a large university comes with the advantage that we can team up with like engineering and some smart people who are able to build all that together with us. And it's especially like Rob's work, who is looking into multisensory immersive experiences and trying out how to make it more comfortable for the user, so to enable people to stay longer in the immersive environment. So I'm a person who becomes cyber sick very, very quickly. But if I were a person who would need to use it for training or upskilling, like in the aviation industry, it would be really great, of course, to have environments that wouldn't make me so sick, or at least not as quickly as they do. And it turns out that, like, if we are able to produce additional stimuli to the immersive experience, that you can actually decrease the cyber sickness, and that's like especially what Rob and the group of students and staff around him are doing here.
That was a very, very good quote, because it brings us to Daniel. Daniel is also, well, actually since 2 days he's not a Emmett student anymore, because his thesis was assessed. He's basically done. Congratulations again, Daniel. But Daniel did work on mitigating cyber sickness in 6 degrees of freedom movement in virtual reality. And you might think, well, what is 6 degrees of freedom movement in virtual reality? Well, obviously that's flying a broomstick like Harry Potter by playing Quidditch. Would you like to explain a bit more?
So, if you come over here. So, basically, we built this apparatus here that you can sit on, and wear a virtual reality headset. And there are buttons, so you can basically fly around in this 3D world and fly through these hoops. And part of my master's thesis was assessing how it affects cyber sickness and ways to mitigate that. So just trying different things and seeing what effect they have.
Can you show us what one would see? Can somebody go in there at the moment, or?
Yes. Do you want to go? Or
Yeah, sure. Why not? Somebody else would have to explain to what I'm doing. You need to know that I think Daniel was the only student that didn't really struggle to find participants for his study, because everyone wanted to be Harry Potter and fly on a broomstick. And yes, I understand that, because it's just an awesome experience. Okay. Woo!
okay, so
Oh, that
should be ready to go.
yes. Well, I missed one. So I'm pretty sure you should be able to see that I'm just flying over Hogwarts, and I'm leaning into to get a bit into the mountains. I'm normally
We can actually pay you to do this.
I'm getting better. I missed a lot of the hoops, but I'm now a bit more under control. Past the Dementor, and then coming back to the Quidditch field where we'll stop.
Smooth ride.
Wow.
So what Daniel has actually done, he's looked into different modes on mitigating cyber sickness, and one of the modes was basically using eye trackers and using vignettes to basically reduce the amount of details that are displayed in the HTC Vive. Another one was giving vibro feedback so that you feel that you're basically moving.
What was this score?
Oh, and the embodiment one, so you could either see your hands or you could not see your hands while you were on the ride.
So there's one actually question coming up for Daniel. So Justin is asking, how did you build the entire magical world?
So
Talk to the camera.
most of the assets I managed to get from the internet for free, actually, and I just used Unity 3D to put everything together, and with some terrain generation, it all kind of came together and seems to work quite well.
Okay, I think we go over to Rory, right?
Yep, if you want me to demo next.
Yes.
So, kia ora koutou. This is my PhD project. So this is working with Fire and Emergency New Zealand on creating air attack firefighting, wildfire firefighting simulator. So what they do is they go out and fight the bushfires using helicopters and fixed-wing aircraft. And basically they have a very lack of training opportunity. As you know, you can imagine that helicopters and fixed-wing aircraft are quite expensive to put up, let alone just for training. So, for example, this Port Hills fire was a multi-million-dollar fire response. I think it was about $7 million total. And to do a training, it's about $200,000 a day. And we built this system for not even 100 grand. So we're looking at probably even like 30 or 40 grand it would cost us to put all this together. So you can see how that becomes very cost effective for them to use as a training tool. And not only that, they can use this tool any time around any of the year, basically. So any day of the year they can come in here and use this as a training tool. So I used this to do my PhD with, and completed that maybe 2 years ago now. So, and we're still getting asked for them to come and use our system to help train, so that's really good. So basically what we've got here is a two-person 270-degree simulator, and we use flight simulator software. So this is prepared, so it's a flight sim software that Lockheed Martin have taken care of. And so they've basically bought the original Microsoft flight simulator. And yeah, so and there's an SDK for it, and you can add all sorts of different effects. So here we've got a fire effect, and we create a multi-person training response. So when we have the training here, we generally have 3 or 4 other computers running as bucketing helicopters, and the people who sit in this seat, we've got 1 pilot and 1 air attack supervisor. And the air attack supervisor's role is to coordinate all the aerial assets and send and receive communications through the general communications system. And yeah, so we evaluated all their ability to extinguish the fire and use things like biometrics to measure their heart rate variability. And we used that in this system, and also we took that out into the field and measured their biometrics out in the field, so when they're up in the helicopter. And we compared those 2 sets of data, and we discovered that they're very similar in their HRV and that sort of thing. So we concluded that it's creating the same level or a similar amount of stress as being out in the field. So yeah, it was a really great project to work on. Hopefully we can keep it going into the future. So yeah, this is like a 2-year-old piece of tech now. So there's lots of new systems out there. A big demand they want is to have a big, more portable system. So I think using things like head-mounted displays. We did try that in the past. Back then the tools weren't that great, so that's why we kind of settled more on this. But now the tools are coming better and better. So like for instance, you couldn't really read what was on the gauges that well because of the bad resolution for the headsets back in the day. But now we've got really higher powered resolution headsets. So we're really keen to try that out again. Yeah, if you're keen to hear more about it, like I love talking about this, it's my wee baby, so yeah. Not sure what else to say, but yeah,
that's pretty good. Thank you, Rory.
Thank you.
We'll move on to the final demo, which is on the Nova Ball H360. I'm not too sure whether we have a candidate in there.
We do.
We do have a
Mark
candidate.
in there.
So let's join the view for a second with Mark. Hi,
there.
Mark. How are you feeling in there?
Feeling great.
You're feeling great. Okay.
Famous last words.
Famous last words. Oh yes.
It's from a New Zealand company. We call it also the Warp, which is like related to the Zorp, a tourist attraction in New Zealand where you can like put yourself into a similar ball and roll down hills. Here you can experience virtual reality. Ryan created a little game to experience it, and it will move directed by Mark in all directions. I hope that you will be able also to see what Mark's Mark sees.
You getting okay? Yeah. Right.
Then he starts the ball and moving around. So at the moment we are simply testing like how it functions and how to develop for it, how to use it. But in the future, we hope that we will be able to use it also for training purposes, for experiments, and of course, like a very obvious use case scenario is again aviation and pilot training. But I hope that we will be able to also create scenarios, for example, for mental health applications. So like create like a floating and calming scenario where it's not like so intense, but maybe even very nice to use the ball and become calm, fight anxieties. So that's like all the things that could be done with the ball. And I think Mark's doing really well.
I think you can see at the moment, anyone correct me if I'm wrong, but it's a demo application for the Nova Ball that was developed by one of the interns that we had last year for I think 2 or 3 months. And yeah, for all Star Wars fans, they will recognize what it is about, so I spare you the details. But it's a really awesome experience to be in there and try this.
I very much hope that Mark will feel fine after the experience
He looks very engaged.
and relaxed.
He's trying to
He
beat,
says it's good, yeah.
trying to beat Tom's high score.
And what might be important to say is, like, if you see this technology here, we are always open for collaboration. So if you would like to work with us on the Nova Ball and run some studies or run some interesting projects, you're welcome to contact us. Actually, that's not only about the Nova Ball, that's about all the technology that you've seen here. So we are very open lab, and we are very happy to join new collaborations and work on joint projects or ideas that you might have. Are we doing? Do we have any questions coming in?
They're all saying great, impressive, and not really questions so far.
No questions so far. So if you have questions, even if you are 20 seconds behind, I need to say that, please post them on the YouTube commentary, and I think we will stay here for a moment, because that's basically also the last station of our tour. So,
And we hope very much that we were able to show you the incredible and amazing place that we're in. Thanks to Tom and Mark and Rob, and all the wonderful toys that we are able to play with and use for like the meaningful research that we are carrying out.
So there is actually a question
Oh.
coming in. So we're not getting close to the camera so we can hear. Well, this name is very long. Tafiz Tafazani. Yeah, he asked, could the Nova Ball be a good way to simulate skydiving or free fall experience?
I don't think so. The reason why I'm turning around is because behind me here is Daniel, and he's he's on the edge of thinking, staying in the Hitler and staying the Hitler behind. But while he was waiting for the assessment of his master's thesis, he was actually working on another prototype, which is about simulating skyfall activities in the tractor cage, which is looking similar to the broomstick setup, but it's more on a platform where you need to lie down, and then you are supported, and then one... Is it around? Oh, yes. Oh, it's down there. So... Is it really heavy? Kind of.
Everyone's looking at it.
So this is a system that Daniel at the moment is working on, and it will be put into the tractor cage and will allow you basically to have free fall experiences, right?
Yeah, so you lie down in this thing. Have it.
I haven't seen it yet, but I already lay down on that platform, and it's possible. And I'm looking forward to experience it.
Well, this would be good for hang gliding kind of thing, parasailing.
The Nova Ball. No, this one.
No,
Yeah,
this one.
as well. Okay.
Because one of the problems with skydiving is something called gravity,
Okay. Yeah.
sort of zero G.
Yeah.
You've
And we
got-
could build a supporting system from the top that pulls you up a bit.
Yeah, but you need to drop. The person, you know, at
Yes.
least a while they have 0G. So I think,
That's true.
Daniel, what you need to do along with this is build an anti-gravity machine. And what you do is you put the anti-gravity machine there on the base, you know, it switches off gravity, so now you really do feel like you're free falling, and then you can really do all these other things. That'd be a good PhD, actually.
It's also nicely scoped for 3 years.
Yes.
But that's skydiving kind of simulators, that big fan at the bottom, and you know.
Oh yeah,
you
right.
jump in
Yeah,
there.
yeah. You get the wind blast.
Yeah, you've got your VR goggles on there, and then that'd be quite interesting.
And then if your chute doesn't open,
Yeah, yeah.
you could. That's when you drop them from the ceiling. You know.
I'm also a passionate scuba diver. We basically experience zero gravity the moment you're underwater. So basically, I also built a nice water tank
That's
here.
true. Yeah, you could do that. Yeah.
Is there another question, Chris? Not yet.
You see what happens if you put a lot of academics into a room. The moment they start thinking about what they could do with cool
Just
technology.
said use GBS. I don't know what is the GBS.
Expand on that acronym. I think.
No, he says galvanic vestibular simulation.
Oh yeah,
tool
yeah.
3.4.
Okay, yes.
Okay.
Good point. You know
do
what
that.
that is the electrical stimulation
Yeah.
to the cortex, and it's a motor neuron system, and then you can basically screw up your inner ear feeling of gravity, and then you think you're free falling. Good idea. See? There you go. Yeah.
Sounds portable.
Yeah. Sounds better
Yeah.
like a
Yeah.
like using huge fans or building a tank for scuba diving. The last one, this might be really nice.
Sounds very challengeable on ethics application.
Yes.
Oh yes, that would be interesting to go through your human use.
But people have done that. There have been famous experiments by colleagues in Japan as well, like the remote-controlled human. So there are people walking on a soccer field, and the remote controller is used to basically stimulate your what is it? Your perception of missing the word. But basically, they could give you the feeling that you're leaning over to the right, and then you were basically
Vestibular.
yes, vestibular
Yes.
stimulation, and then they could basically steer you left and right walking there.
Of course, they could also
I'm not
excite
sure
your
about
muscle
their
group.
ethics application though.
Yeah. You could actually stimulate their muscle group.
Yes, could
Yeah.
do that as well. But
Yeah.
they use the vestibular
Yeah.
stimulation for that one.
Mhm.
So, Jonathan, I think is following the GBS question. He asks, does the participant present motion sickness after finishing, like experiencing the electronic signal scrambling, you know, the brain, something like that?
I need to be honest here, I don't know. I think it's like with all the other experiments as well, it will be an individual thing, individual experience. And some might be more prone to that and some might be less prone to that. That's also what Daniel experienced in his experiment here. So some people were really like out in, let's say, 10 or 20 seconds. And some didn't experience any kind of cyber sickness. It really depends. Yeah. But I'm not sure whether GBS is doing any better there. I don't know.
Sounds like a very questionable research technology at the moment.
Well, it's worth investigating. That's what we're here for, right?
Yes.
That's right.
Yeah, and I think if you are clear about the possible consequences to the participants,
Yeah.
As long as it mean no harm, should be good.
Yeah.
great.
I think.
I think so far, yeah.
Okay. I'm not so sure, but I think time-wise,
About it 1 hour time.
yeah. So that I would say, well, thank you for joining us on the 360 tour of the HIT Lab. Thank you everyone who is still around here and helped us and doing the tour. That's Ryan over there. Mark actually doesn't leave the Nova Ball anymore. If you are looking for Mark in the future, you might have to come to the HIT Lab. But this basically concludes our tour. And does anyone know what the next program
Yeah,
item
next
is?
one is a student presentation. We'll get
Next
back
one is
to
a
all-
student presentation, and then you will again meet, Tim, who you have seen in the Omni treadmill, and he will guide you through the student presentation of recent and current post-EMIT student projects and PhD projects. Thank you very much for joining us.
Thank you.
Coffee dudes.